video we will discuss two simple problem. A horizontal line PQRS is 12 meter long, where PQ is equal to QR is equal to RS, which is equal to 4 meter. Forces of 1000 Newton, 1500 Newton, 1000 Newton and 500 Newton acts at P, Q, R and S respectively with downward direction. The lines of actions of these forces make angle of 90 degree, 60 degree, 45 degree and 30 degree respectively with PS, which means horizontal beam. Find the magnitude, direction and position of the resultant force. So this is the problem, and see the distance between PQ and QR and RS, which is equal to 4, 4 and 4, right? And the forces 1000 Newton, 1500 Newton and 500 Newton acts at PQRS. So at P 1000 Newton is acting, at Q 1500 Newton is acting, at R 1000 Newton is acting, and for S 500 Newton is acting, and the line of action of these forces makes an angle 90 degree. The first force 1000 Newton is acting at point P, which is at 90 degree, and at Q, which is 60 degree with respect to horizontal axis, and 45 degree for next force R at 45 degree, and last one the force acting at point S, which is 30 degree, right, with respect to horizontal. So now we have to solve, and we have to find the magnitude of the resultant, we have to find R and the direction, theta and the position, right? So we know that already the force is acting with some inclination. We have to resolve the forces into two, right? So this 1500 is acting at Q is divided into two forces. One is horizontal force, another one is vertical force. Just draw a line vertically, and this is opposite force, and the force arrow mark is towards downward. So draw downward arrow. So this is the vertical force and this is horizontal force, right? So opposite side, which is 1500 into sine 60 degree, and here 1500 into cos 60 degree, right? Similarly, you have to draw a line vertically, and the arrow mark is towards downward, and here this is opposite side. So 1000 into sine 45 degree, and the horizontal force in this direction, right? Horizontal direction, in this direction, right? So this is vertical force and this is horizontal force, right? So horizontal force 1000 into cos 45 degree, right? Similarly, in this force is divided into two. Draw a vertical line, and so arrow mark is downward, right? Here the arrow mark is towards left side, right? So this is opposite side, so that's why 500 sine 30 degree, and this is 500 cos 30 degree towards left side, right? So now solve the forces horizontally and vertically, right? Now sum of horizontal forces, which is equal to 0. For first force there is no horizontal force. For second force, the force is acting left side, and the force acting at point R, the horizontal force acting left side, and the another last one is also acting left side. So sum of all these forces, then you will get horizontal forces. Sum of horizontal forces, which is equal to 1500 into cos 60 degree, right? So now let us calculate 1500 into sine into cos 60 degree, right, which is equal to 750. First force 750 plus second one 1000 into cos 45, which is equal to 707, 707.10. The last one, which is 500 into cos 30 degree, which is equal to 433, 433.01. So sum of all these things, 750 plus 707.10 plus 433.01, which is equal to sum of horizontal forces, which is equal to 1890 Newton. Similarly, sum of vertical forces which is equal to 0. So add all the vertical forces here. 1000 Newton is there, right? So 1000 Newton, 1000 is downward, right? All the forces are acting downward, so sum of all the forces. So downward 1000 Newton into 1500 sine 60, right? 1500 sine 60 degree, right? So plus 1000 into sine 45 degree plus 500 sine 30 degree, right? So now 1500 plus 1500 into sine 60 degree, how much? This is 1000 plus 1299, right? 1299 plus last one, last before 1500 into sine 45, which is equal to 707, 10. The last one, which is equal to 500 into sine 30, which is equal to 250, right? So sum of all these forces, which is equal to 1000 plus 1299 plus 707.10 plus 250, which is equal to sum of horizontal forces, sum of vertical forces, which is equal to 3256 Newton, right? So horizontal forces equal to 1980, horizontal forces equal to 1890, 1890 Newton, and sum of vertical forces, which is equal to 3256 Newton, right? So now we have to find the resultant. We know that the formula, which is equal to root of sum of horizontal square plus sum of vertical forces squared, right? So take a root, and 1890 squared plus 3256 squared, what is the value? And root of 1890 squared plus 3256 squared, what is the value? 141,73636, and root of this, which is equal to 3764 Newton. This is the value of R, right? So now we have to find theta, which is equal to tan theta, which is equal to vertical by horizontal, which is equal to vertical how much? 3256 divided by horizontal 1890, right? So tan inverse of 3256 divided by 1890, right, which is equal to 59. So theta, which is equal to 59.86 degree, right? Let us check. 1890, which is equal to horizontal value, and vertical value 3256 we got, and the magnitude, which is equal to 3764, and the last one theta, which is equal to 59.86, right? This is how we have to solve the problem. I hope got idea. Okay, and now the next problem. A uniform plank ABC of weight 30 Newton and 2 meter long is supported at one end A and a point B 1.4 meter from A as shown in the figure, right? Find the maximum weight W that can be placed at point C so that the plank does not topple, right? So two supports are there and W is acting beyond the support, right? So now we have to take moment about B. So this is actually 30 Newton is acting downward 1 meter from A, and W is acting at point C, and the distance from point A, which is equal to 1.4 meter and 0.6, right? So now take moment about B. Take moment about B, right? So we know that force into perpendicular distance. Now from B we have to take moment, right? So 30 force, 30 is acting downward, right? This is actually anti-clockwise direction with respect to B, and W is acting clockwise direction, so both are opposite side. So let us take clockwise direction, which is equal to positive, anti-clockwise negative, or clockwise direction which is equal to anti-clockwise direction, right? So now what is the value here? 1 meter is there, distance between 30 Newton and A, and the total distance between A and B, which is equal to 1.4. So what is the distance between 30 Newton and B? 1.4 minus 4, which is 1 which is equal to 0.4 meter, right? So now force into distance, 30 into 0.4, which is equal to W force into the distance, perpendicular distance, which is equal to 0.6. Now W, which is equal to 30 into 0.4 divided by 0.6. So what is the value? 30 into 0.4 divided by 0.6, which is equal to 20, right? So W, which is equal to 20 Newton. It's a simple problem, right? So let us check the answers. W, which is equal to 20 Newton. Okay, thank you.